Hello class, we're working out of your Algebra 1 book, 1.6, dividing rational numbers. So to get started, we're just going to look at regular division and work in integers with that. So you know 14 divided by 2 equals 7. You can rewrite that as a fraction because a fraction bar is a division symbol. And just like improper fractions go to whole numbers, 14 divided by 2 is also 7. Let's try some negative numbers. Because the fraction bar is a division symbol, we are dividing unlike signs. Negative 72 divided by a positive 9 is negative 8. If we try 105 divided by negative 21, we can rewrite this as 105 divided by negative 21. Also, we're dividing unlike signs in this example. And negative 5 times a negative 21 comes back to 105. So 105 divided by negative 21 is negative 5. What if we have something like negative 864 divided by negative 36? We're dividing like signs, so right away our answer is positive. Okay, you can do a lot of strategies here. You can put your negative 864 inside the house and divide it by a negative 36 in long division. You can also reduce your fraction with a GCF in divisibility rules and simplify it to be able to mental math the resulting numbers a little easier. However you work this, your answer will be 24, meaning 24 times 36 in the negative is negative 864, your big number, working in reverse from division. Okay, a reciprocal of a fraction goes to, it's not equal to, but it goes to 3/2. And that is the reciprocal. Flip it over. Look what happens when we multiply reciprocals. If you use the strategy, 3's cross cancel, the 2's cross cancel, and multiplying by the reciprocal results in a 1. In the reciprocal of negative 5, it would go to a negative 1/5. Watch what happens. We multiply by that reciprocal, and we remember we can put any whole number over 1 to make it look like a fraction. We have a negative times a negative, and we still can cross cancel our 5's and 1's, numerator to denominator, and that negative times a negative throws a positive 1. The product is 1. This is also called the multiplicative inverse. You're flipping over your fraction and multiplying for a product of 1. Might be note card territory. Add that to your notes. Okay, if you remember just regular division of fractions, we have a process where we keep, change, flip. We keep our 4/5, change our division sign to multiplication, and if we do that to keep the problem equivalent, we flip the last fraction if we change the operation symbol. Okay, so 5 and 10 cross cancel. 5 goes into itself once, 5 goes into 10 twice, and now we have our new work to work with. 4 times 2 is 8, 1 times 9 is 9, 8 ninths in the positive. So -5/7 divided by a -5. We're going to apply keep, change, flip. So -5/7 times 1 over 5 in the negative. Put that so we can see it. The two operation symbols sitting right together right here. See that? Times and a negative. Let's put parentheses around that term in our expression to differentiate it. Alright. Our 5s will cross cancel here. And we have a negative times a negative. And since we cross cancel our 5s, this would really be a 1 now. 5 goes into itself once, both times. We work with our new work. 1 times 1, 1. 7 times 1, 7. We end up with a positive 1/7. Let's try this. -1/7/12 divided by 7 3/5. So take these mixed numbers to improper fractions. 12 times 1 is 12 plus 7 is 19. The denominator stays the same and our negative sign will come down in front of it. Still a negative improper fraction. Divided by 5 times 7 is 35 plus 3 is 38. Over the same denominator, 38/5. Okay, we're going to keep, change, flip, and we're going to have a -19/12 times 5/38. So we're going to look for what we can cross cancel. If we think about it, 19 goes into itself once and into 38 twice. There's not a lot of numbers that could work for the GCF of 5 and 12. So we're going to work with 1 times 5 in the numerator, 12 times 2 in the denominator, and remember our negative sign will transfer with that. -5/24 is our final answer. If you're asked to divide 1.26 by 0.3, then 1.26 is in the house, 0.3 is outside the house, and we're going to be sure our decimal here disappears by multiplying by 10. If we multiply by 10 on this side, we have to multiply by 10 on this side. We want that to not be a decimal in that divisor. So if we move the decimal to the right one place here, we need to move it to the right one place here. And what we'll be dividing is 2.6 by 3. 3 fits into 12 4 times. 4 times 3 is 12. 0. Our decimal goes up. Our 6 is a bring down. 3 goes into 6 twice. And 2 times 3 is 6. We're going to have 6 minus 6 and a terminating division problem at 4.2 in the positive. Okay. Let's work with this idea. Okay, we're going back to what we talked about already. If we can make a 1 out of a multiplicative inverse or the reciprocal, then we use that idea when we're dividing by a fraction. So students look at something like this and say, I don't know what to do. Well, I'm going to multiply the numerator and denominator by the reciprocal of the denominator that's sitting there. And if we multiply by a negative multiplicative inverse, that will make our denominator positive as well at the same time. So what happens here is we are multiplying a negative times a negative, that makes a positive. We multiplied by the reciprocal, so 2 divided by 2 is 1, and 1 divided by 1 is 1, and now we have a 1 in the denominator when we use this strategy. But whatever we multiply in the denominator, we have to multiply by the same value in the numerator. And that keeps the equivalency of the fraction. So on top, in the numerator, we have 4 times 2, 8. We have 5 times 1. In the denominator, 5. And it is unlike signs that we're multiplying, so negative 8/5. This is all over 1 now, so our final answer is negative 8/5 without the 1 in the denominator. Let's try it again. 2/3 divided by 4. Multiply numerator and denominator by the reciprocal. So any whole number can be put over 1. Now you can see the cross canceling, if that helps you. 4 divided by 4 is 1. 1 divided by 1 is 1. That leaves a 1 in the denominator. Now we're going to go up here and work. 2 times 1 is 2. 3 times 4 is 12. Okay, this is going to be equal to 2/12 when we drop the 1 off the denominator, which is then equal to 1/6 in simplified fraction form. Okay, so on page 37, there are examples of all your properties. That is note card notes territory for the commutative, associative, identity, and zero properties, whether addition or multiplication, whatever it falls as. Also, write down examples of those. So fingers walking to page 37, look over all of those properties and how they apply with real values for examples. I hope this helps, and I'll see you soon.